Hi everyone, so today will be my last video for Algebra 2 Honors for this year, and please stay with me through the whole video because I would like to say goodbye at the end. But let's get right to the lesson. So we have just one more thing to cover, and that's how to solve equations that are either in exponential form or logarithmic form. So let's go ahead and get started. So for number 1 through 5, you have exponential equations. So they are called exponential because the variable is inside of the exponent. So like for instance on number 1, the variable x is part of the exponent, so that's exponential. So all exponential functions require the use of logs. So I'm going to go through the bullet point steps that are at the top and explain what each of them mean, but it's really not that difficult. So for number 1, the first bullet point, it says isolate the exponential expression. So the exponential expression would be the part that contains the exponent. So the 2 is the base and the x is the exponent. So there's nothing to isolate here, that part is already done. So skip over the first bullet. So then the second bullet is to change this from exponential form, b to the x equals y, to logarithmic form, log base b of y equals x. So this is what we covered on not the last lesson, but the one before that on logarithms. So I'm going to change this to a logarithm. So remember, you abbreviate it log. Whatever the base of the exponential equation was will be the base of the logs. That will be 2. The number here after the equal sign will be the number you're going to take the log of. And then the answer will be x, which is the exponent. Okay, so we're going to need to do our calculator next. So I'll have to go back and forth with the calculator quite a bit today. Apologize for that, but I want you to see everything that needs to be done. So here we have it. So I showed you how to do this on the logarithms video a couple times ago. So it hasn't been that long ago, but I'll remind you. So some of you might have math, and then all the way down to the bottom, you may have the choice to do a log base. So if you have that option, choose that, and you will put in the 2 for the base, and the 18 as the number inside the parentheses. Okay, so then you should get this answer. Now we're gonna always round to the thousands place if it's not a whole number, so I would say that's 4.170 rounded to the thousands place. Okay, now I know some of you don't have this option when you go to math, so you would do the change of base formula, and here's a reminder of that. You would do the log of the 18, that's the common log right beside the number 7, and you would divide that by the common log of the base, which is 2. So you should get exactly the same thing by doing it that way instead. So either way is fine. Either way, you would round to 4.170. Now with all of these equations, you should check your answer by plugging it back in for x. So the original equation was 2 raised to the power of x. So I'm going to raise it to the answer. That's right there with the negative symbol. And then press enter. And you'll see that it does equal that original number 18. So that means our answer is correct. So I want you to check all of them to make sure you're doing it right. Okay, so then back to the drawing board. I'm just going to jot down that answer real quick. To the thousands place, x would be 4.170. Okay, so number 1 was pretty simple and it's done. So number 2 will be pretty easy as well. So this one is 10 raised to the 3x power equals 77. Okay, so currently that is exponential form. We're going to change it to logarithmic. So you're going to write a log, and the base of the log is the same thing as the base of the exponential, 10. However, you do not ever write the 10. You do not write anything. If you just write log with no base, that's understood to be 10, and that's how it should be done. So you would say log of the number 77 equals x. So remember, the 10 is the base, but you just won't see it here. Don't write it. Okay, so this one will be really easy. We just have to do the log of 77. So since the base is a 10, we just use the common log button, the right one right beside the 7. So you would just put log 77 equals, and then you're going to get this answer. Now there is one last thing that I forgot. the exponent was not just an x, it was a 3x. So think of this number being equal to 3x. So you would need to divide that answer by 3 to get x. Sorry about that I forgot that. So our answer divided by 3 will be this. So if you were to round this to the thousands place, that would be 0.629. And you would be able to check this by plugging it back into the original equation. So it would be 10 raised to the power of 3 answer. So if you put in 3 answer, you would get the original number 77. So back over here. So what I should have put instead of an x over here would be 3x, and then we divided by 3. So that's why I took the answer and divided by 3 earlier. So when we did the log of 77 and divided that answer by 3, it worked out to be 0.629 after it was rounded to the thousands place. Okay. So that's 1 and 2. Those are pretty easy. The rest of these are not difficult. It's just you got to do a couple more steps. Not hard. Okay, so number 3, we have 5 raised to the x plus 2 power minus 3 equals 42. Okay, so in this problem, the negative 3 is not part of the exponential expression. It's not being raised to any power. So you would want to eliminate that right away. So rather than subtracting by 3, of course, we would add 3. So do that first. So we would still have 5 raised to the x plus 2 power equals 45. That is what that first step of isolating the exponential expression means. Okay, so then we will change this to a logarithm. The base 5 of the exponential will be the same thing as the base of the log, base 5. The 45 will be the number that we take the log of, and then it will equal the exponent x plus 2. Okay, so remember the exponent was not just x, it was x plus 2. So what we would have to do is subtract 2 from both sides to get x. So x will be log base 5 of 45, and then we'll have to subtract 2 once we get to the calculator. So this is what we're going to be putting in our calculator in just a minute. Log base 5 of 45 minus 2. So let's go do that. Okay, so some of you have the choice to go to math and all the way down toward the bottom for log base. I'm going to go there. And you put a 5 for the base, and the 45 inside of the parentheses. And then out of the parentheses, make sure you're out of the parentheses, then put your minus 2. So this would be your answer. Rounded to the thousands place would be 0.365. Now if you have a different style calculator, you would do the change of base formula. So you would do the common log of 45 divided by the common log of the base 5. Make sure you close the parentheses and then put subtraction by 2. And you'll get the same exact thing. So if your calculator is different, no worries, it'll still work out. Okay, so either way, you'd be able to check your answer by plugging it back in. So you would put the 5 in, raised to the power of the answer, remember that's with the negative symbol, the answer plus 2, and then the minus 3 was separate. So on my calculator, I know I have to go to the right arrow and then put in minus 3. But some of you might need to put the exponent in parentheses, like 5 and then parentheses, answer plus 2, before you put the minus 3. You'll have to kind of play it around with your calculator. So you get 42, which is what the original equation had. So that's correct. Okay, so number 4, we have e raised to the x power is 56. So So remember, e is actually a number. It's approximately equal to 2.71828 and so on. It's called the Euler number or the natural base e. So whenever you have an exponential equation, remember the x is part of the exponent, you solve it using a log, but because the base is an e, you would use a natural log. So that is abbreviated ln. I saw some of you writing in, like a capital I. That is not an I, that's an L, like log natural log. It's a Latin word, logarithmus naturale. So that is an L, not an I. Okay, so you would be doing the natural log of 56, and then that will equal what x is. So that's all we have to do is figure out the natural log of 56 for that one. Okay, so the natural log button is right beside the number 4, ln, not in, and 56 was the number. And we get this number, so rounded to the thousands place, I would say that's 4.025. And you check it just like anything else. You would go to e to the x, that's the second natural log, that gives you the e with the exponent, and just put in the answer right there with the negative symbol. And you get the original number 56, so it is correct. So 4.025. Okay, so I didn't write the answers for these. Let me do that real quick. Number 3 was 0.365, and we already had checked that one. And then this one that we just finished was 4.025. Okay, so that's number 3 and 4. So there's one more of this type of problem. And notice it also has an e in it. So we have 2e raised to the power of 4x minus 1 equals 92. Okay, so the first step, remember it says, is to isolate the exponential expression. The e is the base with the x as part of the exponent. So this is the exponential expression. But the 2 over here is not being raised to any exponent. So we want to eliminate that right now. So I'm going to divide both sides by 2 before I do anything else. So it will be e to the 4x minus 1. And if you do 92 divided by 2, you would get 46. Okay, so then we would go to using a log, and because the base is an e, I'm going to use a natural log. So it's ln. The number will be 46 that you take the log of, and that will be equal to 4x minus 1. Now it's not just an x over here, it's got the 4x and the minus 1, so you have to do a couple of things. So I am going to first of all add 1 to both sides. Now when you add 1 to this side, you don't add it to 46, it's going to be separate. So in a minute we're going to be doing the natural log of 46 and then adding 1 to that. So 2 separate things there. Now on the other side I still have 4x. So the other thing I'll have to do is divide by 4. And when I divide by 4, I have to divide the whole thing by 4. So x will be all of this. So this is what we'll put on our calculator. Natural log of 46 plus 1 divided by 4. Okay, so I'm going to set this down and go there. Okay, so you have to be careful on this one, how you enter it in your calculator, because if you're not careful, you'll get the wrong answer. So you have 2 choices. If you want to be able to put the entire thing in the calculator, you would need to use parentheses around the numerator. So you would need to put a parentheses and then natural log 46, close the parentheses, then put the plus 1, close the parentheses, and then divide by 4. This would be how you could enter it all at one time and get 1.207 if you round it. The other option is you could figure out the natural log of 46. You could get that answer, then you could add 1 to it, and get that answer. And then you could divide that by 4 and get the same answer that we did back up here. So that's totally up to you how you do it, but if you want to enter it all at once, you would need to put the numerator in parentheses. Okay, and then I'm just going to check this real quick. So in the original equation, it was a 2, and then e to the x, and then it was 4, and then the answer button, and then -1. And you get 92, the original number, so that means it is correct. So 1.207 will be your answer for number 5. Number 5. Okay, so those are the ones that are called exponential equations because they have a variable inside of the exponent. So the other half of the lesson has to do with how you would solve if there's a log in the original equation. So let's take a look at number 6. So it says we have log base 5 of 3x plus 1 minus 5 equals -3. Okay, so this one contains a log. So we're going to follow those bullet points and I'll show you what each of them mean. So isolating the log, this over here would be considered the log. The -5 isn't part of that. So I'm going to eliminate that right now by adding 5. So I would still have the same log for now. Nothing has changed. But rather than this -3, I would add 5 to it and get 2, of course. Okay, so now we're going to do just the opposite of the other equations. And we're going to take a log expression and change it over to exponential. So this was in the lesson, not the last lesson, but the one before that. There were some questions where you had to change one to the other. So the base of the log is 5. The answer over here, the 2, would be the exponent. And then that will be equal to whatever this number is, 3x plus 1. So this is the equation that you would solve. So you would figure out 5 squared, of course that's 25. And then this is just a little linear equation to solve, so very easy. Subtract 1, so it'd be 24 equals 3x. Divide by 3, so 24 divided by 3 will be 8. Now you would still want to check these, so I'll show you how that is done. Let's see if 8 is correct. Okay, so some of you have that log-based choice in math, so I'm going to go there first, all the way to the bottom. Is log base. So it was a 5 base. Inside the parentheses, you would put 3 times, we didn't use a calculator for this, but you'll just have to put in the 8 yourself. 3 times 8 plus 1. Then you would need to go outside of the parentheses and put your minus 5, subtraction by 5. And you will get -3, which is what it should have been. Okay, so if your calculator is a little different, you'll have to do change of base. So you would do it like this, log 3 times 8 plus 1, that would stay the same. But you will divide it by the common log of the base 5. And you still have to subtract 5 outside of the parentheses. So if you notice, you'll get the same thing. So either way, -3 is correct. Okay, so that means our solution 8 is fine. So why am I checking this? Well, a couple of reasons. One thing, I want to just check my work, but another thing is you could have extraneous solutions. That means you could plug the answer back in and it doesn't equal what it should. So always check your answers when it's possible. Okay, so 8 was correct for number 6. Okay, number 7, we have 6 plus, there's a log with a base of 4, and then x plus 5 equals 9. Okay. So we're going to isolate the log first. So this part over here would be the log, so the 6 is not part of it. So I'm going to subtract the 6 right away. That will get rid of that. I would still have the log for now. Nothing changes there. and then 9 minus 6 is of course 3. So now you're going to change this to exponential form. So the base of the log will be the 4, the 3 would be its exponent, and that will equal x plus 5. So if you were to figure out 4 cubed, that would be 64 equals x plus 5. And then to solve for x, you would subtract 5. So 64 minus 5 would be 59. So your answer should be 59 for number 7, but I'm going to check it out with the calculator right now. So how to check this? You would put the 6 first, then the addition sign, go under math all the way to the bottom for log base for some of you. And the base was a 4 this time. Inside of the parentheses we have x plus 5, so that would be, in this case, 59 plus 5. Go outside of the parentheses and press enter, and it does equal 9. So if you don't have log base, here's how you would do it. You would still put 6 plus, but you would do common log 59 plus 5 divided by the common log of the base 4. And then that should still be 9, and it is. Okay, so you just have to put it in slightly differently. Okay, so number 8, 4 log, in the parentheses is 2x minus 6 equals 8. Okay, so again, the log is this expression here, not the 4, so I'm going to begin by dividing by 4 right away. So I would still have the log, that doesn't change yet, and then 8 divided by 4 would be 2. So now I'm going to change that to exponential form. Now notice there is no base written. When there is no base written, that's a 10. That's understood that a 10 is really there. So it would be 10 raised to the second power, or 10 squared, and then 2x minus 6. So then 10 squared is of course 100, equals 2x minus 6. You would add 6, so you would get 106 equals 2x, and then divide by 2. So x will be 53. 53 should be the answer for number 8, but let's find out. Let's go to our calculator. I'm trying to make this as quick as I can, so stay with me. Don't tune me out yet. Just a little bit more. Okay. So this one will be much easier to check because the base is a 10. So put in the 4, and everybody can just use the common log button since it was base 10. And then it would be 2 times 53 minus 6. And enter. And you do get the 8 that we needed. So number 8 is correct. It's 53. Okay, just 2 more. Now notice that these both contain natural logs, so these are a little bit different. So hang tight just a little longer. 9 will be the natural log, that's ln, of x minus 2 equals 4. Okay, so this is already isolated. There's nothing to rearrange. We will go straight to the step of changing that to exponential form. Now, if you ever see a natural logarithm, ln, that means the base is e. So you will use that for the base of the exponential expression. The 4 will be the exponent, and then that will equal x minus 2. And then we will add 2 to both sides. So you would have e to the 4th plus 2 will be what x is. E to the 4th plus 2. So let's go see what we get for that. Almost done. So we're going to do e to the 4th power. And I need to press the right arrow to get out of that, and then plus 2. You may have to put yours in parentheses, the 4 I mean, and then put the 2 outside. You just have to see if you get the same thing. But it should be 56.598 if you're doing it correctly. Okay, so checking that one, this will be easy to check too. The natural log button is right beside the 4. Just press ln and put in the answer. That's with the subtraction symbol. The negative symbol. The answer -2. And you should get the original number 4. So that is correct, 56.598. Okay, so for number 9, your answer was 56.598. Okay, so one last one. We've got 3 plus, and that's natural log, 2x plus 7 would be equal to 9. Okay, so this is the natural log. The 3 is not part of it, so I'm going to subtract 3 right away from both sides. So I would still have the natural log for now. That doesn't change yet. And 9 minus 3 would be 6. Okay, so now we're at the point of changing that to exponential. So any natural log has a base of e, so it will be e raised to the 6th power equals 2x plus 7. And I got to do a couple things to isolate the x, so I'm going to first subtract 7. So that would be e to the 6 minus 7 equals 2x. And then I will have to divide by 2. So x will be whatever this is on your calculator, e to the 6th minus 7 divided by 2. Okay, so let me go over that real quick. This will only take about a minute more. Okay, so it depends on if you would like to do this in one step or several. So if you want to do it all in one step, put the numerator in parentheses. So you would have e raised to the power of 6, press the right arrow, subtract 7, or some of you might need to have the 6 in parentheses, not sure of your calculator. Close the parentheses, and then divide that by 2. And here would be your answer, 198.214. If you wanted to do it separately, you could do it one by one. You could do e raised to the power of 6, get that answer, subtract 7 from that, get that answer, and then divide by 2 and get that answer. And notice it was the same thing as it originally was, so that's totally up to you, but you got to do it either separately or with parentheses. Okay, so checking it will be easy. Just use 3 plus the natural log button right beside 4, and then it would be 2 times the answer plus 7. And then that will be the original number 9. So that is correct. So 198.214. Final answer for the last one. Number 10 is done. So just hang on one more second. I want to say goodbye to you since this is the last video. So just give me 1 second. 198.214 would be number 10. We've already checked it. Okay, y'all, like I mentioned several times, this is our last video. Once you do this assignment, you'll be done with my class for the rest of the year, and I hope that you all made it okay through this. It certainly was not an ideal situation, but we did what we could, and I know all of you really wish we were probably in school right now, and I do too, but we made it. So I know some of you really worked hard during this time, and you really cared about learning, and I'm glad that you did that, and I hope that my lessons were able to help you continue learning and that you feel confident going forward. So depending on what you take next year, you might see me again. Like if you're taking pre-calc, it's probably a 99% chance that you're going to have me again. So I'm looking forward to that, and I hope to see you. And if you take another math class, I'm sorry I won't have you, but you'll see me out in the hallways and around school, I'm sure, because I'm not going anywhere. So I love everybody, and I'm hoping that you're doing well, and have a great summer. Take care. Bye-bye.